All right, you're welcome back once again. My name is Victor Digumore here, and we are looking at coordinate geometry. That is what we are still looking at. We have been able to do some classes behind. Please, if you check out on those classes, you realize that it is necessary you should have checked out on them so that you can have a foundation that can lead you into these questions we are solving recently. All right, this question is a WAEC examinable question, and it is saying find the equation of the line which passes through a point 2, 3 and is parallel to this. In coordinate geometry, when we say that two lines are parallel to each other, what we know is that, or what we've been able to realize is that their gradients are equal. You understand what I said now? So that if I have a line running like this, and this running like this, and this is parallel to this, the gradient of this line is equal to the gradient of this line. Okay, their gradients are equal. Okay, so if this is m1, this is m2, we will say m1 is equals to m2. It is a proven case, so we are going to use that concept here. We are going to deploy it here. So I will say that from here, since this is a line and there is another line they now ask me to find, I will deploy this now to get that one by virtue of their gradients. So the only thing I have to do is just to rearrange this one to assume the format of the equation of a straight line. And that format is, I will make it to look like y equals to mx plus c. So if you look here now, if I transfer this over here, I'm going to be having y equals to, this will become minus 2x, okay, plus 6. Look at this now. You realize here now that m, which is the gradient, is minus 2. And of course, c is the intercept is 6. You know, we're not talking about this. We are concerning our calculation on that gradient. So I can come back now and deploy the equation, the process or the expression used in calculating or finding the equation of a straight line as that increment minus, okay, that increment which gives us the gradient m. Do we get? So I will, this is y2 minus y1, but I will leave this so that, because only one point is given. So I will use this y equals to 1 point there. Y is minus 3. Okay, y minus into minus 3. Okay, all over x minus the value of x there is 2. This is equals to the gradient minus 2. So with this now, I can be able to penetrate into that equation that is not given and calculate it and find it. So you realize that if I cross multiply here, simply, I'm going to be having y plus 3 equals to, this into this is minus 2 bracket x minus 2. So this is minus 2x plus 4. Yeah, 1 times this is this. So this is y plus 3. So I can rearrange this now to look better, or to assume this format. I can now transfer this 3 over there and have y equals to, this is minus 2x, and this will become 4 plus 4 minus 3 minus 3. So I will have y equals to minus 2x. This will become plus 1. Okay, you see that this is another equation of a straight line, and it has the same gradient as this one. Look at it. It has the same gradient as, the gradients are minus 2, and the gradient of this one is also minus 2. Obviously, you realize that this line and this line, they are parallel to each other. They are parallel. So I've explained two things right now. What makes two lines to be parallel to each other, and their gradients. and some other calculations, how to derive the equation. So almost three things I've been able to show us now. All right, I believe that what we did has been able to assist us in one way or the other. And if that is so, please like what we are doing, subscribe to the channel, and also click on the notification button so that you can be notified in other classes that we're going to do as well. As you do that, you will not regret. Thank you.